Unit 17, Aqueous Equilibria, pages 249 and 251, a KSP calculation. So we'll continue with the theme of the common ion effect, but now we're going to look at it in a solubility problem. So example 17.82, a 75 milliliter 0.80 molar sodium chloride solution is added to 50 milliliters of a saturated lead chloride solution. What is the concentration of lead ion at equilibrium if this is the KSP? So let me set up my equation. So my sodium chloride is a soluble salt, which means it'll dissociate 100%. So because I have a 1-to-1 ratio here, this 0.80 molar times this 0.075 liters is going to get me 0.06 moles of chloride ions. Now the reason that I did this is because we are mixing 75 milliliters with 50 milliliters, which is going to change the volume. And so before I place this amount here as my initial concentration, I need to know what it will be after the two volumes are combined. So I'm going to take the 0.606 moles and I'm going to divide it by 0.075 liters plus 0.05 liters, which is my 75 and my 50 milliliters combined. And so when I do this, I'm going to get 0.48 molar. And so that's going to be the chloride ion concentration that I would have initially here. So 0.48 molar. We do not have to compensate for this coefficient of 2 because we're going to deal with that later in our equilibrium chart. So we'll set up our ice table here. The initial concentration of lead is 0 and the initial concentration of chloride is 0.48 because of the sodium chloride that we added into the solution. Here we're going to have plus x plus 2x. This is where the coefficient is accounted for. And then we're going to have x and 0.48 plus 2x. So I'm going to set this up with my KSP value so that I can solve for x. 1.7 times 10 to the negative 5 equals x times 0.48 plus 2x squared. Good news, we're going to use, because this is a tiny number, we're going to use the approximation here and get rid of this term. And so to solve this, I'm just going to divide both sides by 0.48 squared. And when I do that, I get a value for x equal to 7.378 times 10 to the negative 5. And remember, because I've solved for x, that has found me this concentration here. And these have a 1-to-1 ratio, so that means I have also found the concentration of the lead chloride. But we actually wanted the concentration of the lead ion, and that is what this amount is right here.